Good morning. Here's our objective today. I will be able to understand that negative exponents represent repeated division and rewrite expressions with positive exponents. So we're going to be able to look at negative exponents and simplify to make them positive. For these first 6 questions, please try these on your own first. We're going to go over the answers real quick, but please do this review 1, 2, 3, 4, 5, 6 on your own right now. Okay, so 4 times 10 to the second. This 10 to the second we know is 100, so this is equal to 400. Exponents are used to represent repeated multiplication. What is the value of 1 divided by 2 divided by 2? 1 divided by 2 divided by 2? Well, this is actually equal to 1 over 4. It's equal to 1 over 2 times 2, which is what we're going to look into today. But you should have gotten 1/4 here. Rewrite 2 divided by 7 as multiplication. That's 2 times 1/7. Multiplying by your reciprocal, just like with fractions. This one is equal to negative 25 because the negative's on the outside. The exponent is not talking to the negative. Whereas this one is positive 25 because negative 5 times negative 5 is positive 25. Whereas this one is just negative 5 times 5. This one is 8 times x times y times x times y times z. Okay. So if the expanded form of 2 times 10 to the 4th is 2 times 10 times 10 times 10 times 10, what do you think is the expanded form of 2 times 10 to the negative 4? Well, the first thing to note is that negative exponents do not mean the number is negative. Just like exponents in general mean repeated multiplication, doesn't mean times 4, it means times itself 4 times. When it's negative, it's the opposite. Remember that negative means opposite. So this is actually dividing by 10 4 times. So we have 2 divided by 10, divided by 10, divided by 10, 4 times. And this is actually equal to 2 over 10 times 10 times 10 times 10, dividing by 10 4 times, which is equal to 2 over 10 to the 4th. So we see that this exponent here, the value stayed, but the sign changed, and it went into a division problem here. Next one, write 6 to the negative 3 in expanded form. Now, before we do that, we're going to look at this key point. The identity property of multiplication states that any number times 1 is itself. Therefore, 1 times 6 to the negative 3 is equal to 6 to the negative 3. So we're going to rewrite this first as 1 times 6 to the negative 3. And in this case, we know that instead of multiplying by 6 3 times, we're dividing by 6 3 times, which is 1 over 6 times 6 times 6. Oop, that's scary numbers. We'll get over it. 6 to the 3rd. So we should be starting to notice a pattern that when you have a negative exponent, it goes to the opposite side of the fraction. So 6 to the negative 3 is the reciprocal of 6 to the 3, 1 over 6 to the 3. Just like here, 10 to the negative 4 became the reciprocal, went on the bottom of 10 to the 4th. Okay. Now, we're going to look at a negative exponent situation. So we have 8 to the negative 2. Now we know that 8 to the negative 2 is actually 1 times 8 to the negative 2, which means 1 divided by 8 to the 2, which is 1 over 8 to the 2. And if we simplify that even more, that's 1 over 64. Now go ahead and look at all of these options and choose for yourself which ones are equal to 8 to the negative 2. And pause the video, we'll go over it in a minute. Okay, so we have A matches, B matches, C does not match because this should be 8 times 8. Matches, E does not match, F matches, G matches, H matches, I does not, and J matches. Let's look at those real quick. So we have here 1 divided by 8 to the second, which is equal to 1 over 8 squared. We have 1 divided by 8 divided by 8 again. Here we have 1 over 64, which is the same. We have the same thing here. We have 1 squared, 8 squared, and 1 squared is just 1, and 8 squared we know is 64. Same thing here, this is literally what we have over here. There's no fraction here, so this one does not work. And lastly, our most simplified form, 1/64. Here are a few more examples. 4 to the negative 3 is 1 divided by 4 to the 3, which is 1 over 4 to the 3. If you can go straight from here to here, you don't need to do this middle step, but this is why we get this. This one here, we get 1 times 7 to the negative 1, which is 1 divided by 7 to the 1, which is 1 over just 7. 7 to the 1, same as 7. And lastly, we have 3 divided by 8 to the 4th, which is 3 over 8 to the 4th. Now, when I was in school, we just learned that the negative sign means to flip it to the bottom, but this actually makes a lot more sense, knowing that it's division, and we know that fractions are actually division problems. So remember, negative exponents represent repeated division. So now, if we have the negative on the bottom, we still know that this means a negative exponent is repeated division. So we have really 1 over 4 to the second. But really, if you just use your pattern, negative exponent means flip it to the other side and take the reciprocal. So we get 4 squared over 1, which this is also equal to if you write it out, which is just 4 to the squared. You can go ahead and cross off that so. Well, I'm going to say so, but you don't need to write it. So let's look at just a couple more examples. If we have 10 to the negative 4, that's equal to 1 over 10 to the 4. If we have negative 6 to the negative 3, that's equal to 1 over negative 6 to the 3, keeping that negative 6 in parentheses. If we have 2 times 4 to the negative 4, that's 2 times 1 over 4 to the 4, which is 2, 4 to the 4. If we have 3 to the negative 6 over 2 to the negative 8, those both flip and you get 2 to the 8 over 3 to the 6. So you have a lot of practice on your own. Please use your notes. Please also use your brains and your neighbors, and good luck.